Hi guys. So the purpose of the video is today is to look at the examples from the properties of quadrilaterals. You won't be required to fill out a whisk over this. I just wanted to post these examples so that you could check the work you've done and make sure that your answers on your examples are correct, or if you've missed class, give you a chance to see what we did today so that you could be caught up with the rest of us. So we're going to start today by looking at this parallelogram. Some things that I know about parallelograms from our exploration the last couple of days would be that the opposite sides are congruent to one another and that they are parallel to each other. So in this example, if I'm going to find x, what I need to do is take those two expressions and say that I know they are equal to each other. I'm going to go ahead and apologize for my poor handwriting today. I left my pen at home this morning, so I'm writing with my finger, and it is not pretty. Okay, so if I'm going to say 2x minus 7 equals x plus 5, I need to get all of my x's together on one side of my equation, so I'm going to subtract x from both sides. That gives me x minus 7 equals 5. And then I'm going to add 7 to both sides to get that x is 12. So they asked me to find x, and I did. They could also ask me how long is AD or how long is BC. They could even ask me how long is AC. To find any of those, I would take this 12 and replace the x with the 12. Example 2 is a rectangle. There are lots of things I know about rectangles. All of the things I said about parallelograms are also true, so the opposite sides are going to be congruent. I also know the diagonals are going to be congruent to each other, and I know that point J is going to be the middle of those diagonals. So all of that information is going to help me find some missing things here. Okay, so they asked me to find Kn. Kn is 4. I've already got that on my picture. And they asked me to find Mn. I've already got that one too. Mn is 3. And then they asked me to find Km. Well, Km is this diagonal. And what I want you to notice is that we've got a right triangle because the rectangle has a right angle. So if I've got 3 and 4, the hypotenuse has to be 5. If you didn't know that triple, you could always work Pythagorean theorem to find that out. Now these remaining segments they've asked me, Ln is also the diagonal, and the diagonals are congruent to each other, so that's a 5. And then all of these that have J as an endpoint, they are all going to be half of the diagonal. So all 4 of these are congruent to each other. So if I look at LJ, MJ, those are both going to be half of the 5, so they're going to be 2.5. And then KJ is also 2.5. Oh, that's really bad, sorry. 2.5, and NJ. Wow, that's terrible. That's an N. J is 2.5. Okay, example 3. Example 3 is a trapezoid. So when I look at a trapezoid, there are some things I know. I know that these lines are parallel. So if I think of this as being a transversal, then I'm going to know that the interior angles on the same side have to be supplementary. So I'm going to take the two expressions, and I'm going to say 12x plus 60 with plus 4x plus 40 has to equal 180. Now to solve this, I need to combine like terms. So 12x and 4x makes 16x, and 60 and 40 makes 100. Subtract 100 from both sides. 16x is 80, and 80 divided by 16 is 5. So that tells me that x is 5. They asked me to find x. And then I can find angle F and angle E by substituting 5 in for that x. So I would do 4 times 5 plus 40. 20 plus 40 is 60. That's going to be this one. and then 12 times 5 plus 60. So 60 plus 60 is 120. And that makes sense because 60 and 120 together makes 180. Angle H down here is 80 degrees. That was given. You just can't read it very well in the picture. So if I view this other side as my transversal, if this is my transversal and these are my parallel lines still, the 80 and the 5y together have to make 180. So that means 5y has to equal 100. So angle G is 100. To solve for y, I would divide both sides by 5. So y is 20. So let's see, x is 5, y is 20. Angle F is 120. Angle G is 100. And angle E is 60. So I've found all those parts. Number 4, only 2 more. Number 4 is also a trapezoid. And when they tell me this one is 60 and this one is 60, that's how I know for sure that this is an isosceles trapezoid. So the trick to doing this one is noticing that I've got a 30, 60, 90 special right triangle. So my ratios on that are x, 2x, and x root 3. So when they tell me 6 root 3, they're telling me that the x value is 6, which means 2 times 6 is 12. So these sides are both 12. So they asked me to find xw and yz. Those are both 12. xw is 12. yz is 12. We're back to, in a trapezoid, you've got the parallel lines. So the same side angles are going to be supplementary. So if I've got 60 already, that makes angle x, the measure of angle x is going to be 120 degrees. And they gave us the measure of angle z is 60, and the measure of angle y is also going to be 120. Since it's isosceles, the angles are going to match. The top 2 will match and the bottom 2 will match. All right, one more, number 5. Number 5 uses a 30, 60, 90, and it uses a 45, 45, 90. So when they tell me that TV is 10, since I know that kites split that short diagonal in half, I'm going to have that this side is 5 and this side is 5. So if I think about a 45, 45, 90, I usually have x, x, x root 2. So that's telling me that TU and UV are both 5 root 2. Okay, now in the bottom part of the kite, I have a 30-degree angle. So these are going to be 30, 60, 90s. Again, because right here in the middle, they intersect at right angles. So if I think about 30, 60, 90, I have x, 2x, x root 3. The 5 is the short side, so it's the x, which means the hypotenuse is going to be 10, 5 times 2. So to find the perimeter, I need to do 5 root 2 plus 5 root 2 plus 10 plus 10. 5 root 2 plus 5 root 2 is 10 root 2. And then 10 plus 10 is 20. And that's as far as I can go unless they ask me to round to a certain place. I could punch that in my calculator and get a rounded answer as well. All right, guys, hope that helps. See you in class.